The advantage. The first one is homegrown energy, obvious, and we don't have a good alternative to fossil fuels, mainly because we don't have less gaseous emission compared to these energy sources, and also we have low maintenance. The other thing is it saves energy up to 50% in comparison to conventional systems. And the good part is it's independent of weather, meaning is that whatever happens in the ground, whether it's rainy, whether it's cloudy, we don't care. There is heat always beneath the earth. So if we are good enough to, if we manage to extract the heat and if we manage to convert it into electricity, this is going to be a good alternative or a good replacement for the renewable, what we call fossil fuels. So we can say it's sustainable source of energy. We can say this is a sustainable source of energy. This is what? Sustainable source of energy. So disadvantage, what is the disadvantage of this thing? I'm not going to talk about this thing, but the first one is it can salinate the soil if the water is not ejected back into the reservoir after the heat is extracted. It should have to be injected back into the reservoir. If not, it could salinate the soil. The other thing is power plants, it can eject H2S, which is the rotten egg. So inhaling this thing could be very fatal. I think these are the main reasons that we have to take care of this thing when we are implementing it, when we are using it to generate electricity. So let's see geothermal reservoirs here. So reservoirs can be suspected in areas where we find. The first one is a geyser, and it could be boiling mud pot, it could be volcano, it could be hot spring, which are suspected for geothermal reservoirs. So we can find them in these areas. So the concept is here, the raising, we don't have here rainwater, right, as you can see here. So we don't have hot rock. So the rainwater, after it pours down, it's going to get hot and it's going to expose as hot water, right? So the point is here, we need to have some technology here, which is permeable, porous, to form geothermal reservoir. So we can trap this hot water in a steam form and we can use it for generating electricity. So reservoirs can be discovered by testing the soil, analyzing underground temperature. There are different equipments that we can different equipment that we can know where we can find the reservoirs so simply. And we have the extraction and use. The heat energy can be brought to Earth's surface by the following ways. First one is direct from geysers or hot springs. Second one is geothermal heat pump. We can use them directly, or we can extract that thing using heat pump. So users are broadly classified as direct use and indirect use. So this one is indirect use. This one direct use, we can say. So direct use of geothermal energy. The first, we can use it for providing heat for surrounding, raising plants in greenhouse and drying crops, providing heat to industrial process. It's kind of direct way of using geothermal energy. The second one is indirect. When we say indirect, we are having electricity generation. Mostly we need to, after the water goes here, after it gets hot or it converted into steam, then we don't have a turbine, and after this turbine starts, we don't have generator. So we can have a tower here on an electricity generation system, so we can deliver the enough amount of power output that we need for our community. So these are the difference between direct use of and direct use of geothermal energy. So thank you. I think this is all about the geothermal energy. I think it was an interesting lesson covering these renewable energy sources, and we will come up with another different lessons for this one. Thank you, and I want you to stay safe. Bye.